Hi Ravi.
Hi, sir.
So you are presenting the data analysis agent, right?
Yes, sir.
Okay, this is a presentation for the solution planning.
Solution planning. Yes, sir. For AI data
Okay,
agent.
yeah, go ahead.
Thank you, sir. Hello, sir. My name is Ravi-Data. I am from non-native background. Here is my LinkedIn ID, and this demo is done through job coaching. My job coach is Shanti Kumar V. This is my coach LinkedIn ID. This is my coach website. So today I perform data analysis process here, and then here you see in my PPT there are the steps for the data analysis. First we data cleaning, then exploratory analysis, then model training, prediction generation, and visualization and reporting. So when I give a prompt, I get these 7 phases to prepare a AI data agent. These are the 7 phases. The phases, the first phase is infrastructure and environment setup. Second phase is the data injection pipeline. Third phase is the vector knowledge base. Fourth phase is the automated ML pipeline. Fifth phase is insight generation engine. Sixth phase deployment and serving, and monitoring and operation. This phase I'm trying to show in my picture diagram. Yeah, and now I explain the how we perform the phases step by step. This is my phase one, infrastructure and environment setup. If we need to prepare in software, first we prepare infrastructure. Here also for preparing a AI data agent, we are first set up environment and uh, backend infrastructure. First, building the foundation for AI data agent. These are the following core infrastructure components. First, GPUs. First, set up GPU servers, the high memory nodes, and distribution storage. GPU servers is provide high speed uh, data to you, and then the high memory nodes is handle large data sets and memory intensive tasks, and the distribution storage is store the maximum volume data to you. The servers is a ML flow, model management and deployment, Chrome DB, vector database, and local LLM, self-hosted large language model. ML is a manage the full ML flow is a manage the machine learning process. Commodities provide the vector database for storing and embedding data like React system, and local LLM is a it's a large language models for the self-hosted, and the third one is the monitoring. Monitoring is a Prometheus matrix collection and Grafana. We are collecting here real-time matrix infrastructure, and Grafana. For the Grafana, we prepare a dashboard for the infrastructure and environment setup. These are some validation framework and security, ensuring the product ready foundation for validation of a checklist. Here you see in my picture diagram, the product ready foundation is ready. First, we set a GPU acceleration. Your GPU acceleration is performing at 100% fully enabled your system, and ML flow is for 100% complete access model tracking. Then Chrome DB is providing API key to you to access, and then LLM use is 85%. They mostly function and some improvement showing in it, and then storage low IOPS, the modest performance uh, to process, and then Grafana dashboard. Here we also see the Grafana dashboard, the most important in making AI data agent by using Grafana dashboards. Here is the how system administrator is perform. system administration is performing the provision resources, install and configure and deploy, integrate. Here is the hardware provisioning. Hardware provisioning is like a GPU server, high memory nodes, and distribution. Here I am showing my phase one. And there is for core service installation, you will be using ML flow server, DB and local LLM, and to deploy and integrate the formalin stack is a Prometheus and we have a dashboard. The hardware provisioning and the core is provided by the validation text, and the monitoring stack is the monitoring checks. This is the as this process we have phase one due to the sign off. Then the second most important phase is a data injection pipeline. The data injection pipeline unified processing of structured and unstructured data. First, we processing structured and unstructured data, and here you see a data flow architecture. Data flow is a structured data path for the structured data about the DAS is a processing. DAS is a scales data processing in a multiple cores, and the data validation ensure the data quality, and the clean data lake is a stores clean and structured data. And for the multimodal data, here is the we use multimodal data path and the frame sampling, clip embedding, and vector storage. These for the multimodal data path. And the next is the vector knowledge base. Or the vector knowledge base components. Here is the embedding models. The convert both structured and multimodal data into high dimensional vectors and enabling unified semantic representation. And in a vector indexing, organize this embedding for efficient similarly search and retrieval. And when ChromaDB storage serves as a scalable and high performance vector database supporting fast and reliable storage and access to embeddings. And the semantic search leverage the vector index to enable advanced and context-aware queries across all the storage data types. ChromaDB acts as a backbone for AI-driven application, embedding powerful retrieval and clustering and question answering over diverse data source. Now, when we are completed phase two, this is a diagram show for external, when we take external data from these sources in the CSV, Paracode, and DB. Structured pipeline is structured data processor goes to DAS cluster and distribute cleaning data validator, gate exploitation, processing data lake, analytics, read structured data. And for image and videos, we multimodal pipeline, multimodal injector, video frame sampler, clip embedding generator, and vector DB writer. For automated ML pipeline, pipeline, these are the components, technology, and function. And this, when we use automated ML pipeline, we use this component: feature engineering, model training, experiment tracking, hypermeter tuning, model evaluation, model registry. In the technology, we feature tools for feature engineering. First, we component showing technology and function. For engineering, we used a feature of tools in the technology, and function is function automated feature generation. For the model training, we use scatterlearn and XGBoost for algorithm execution. Experiment tracking, the ML flow tracking server, parameter matrix logging. Hypermeter tuning, we use technology for Aptuna plus ML flow. And the function is a bisection optimization. And the component model evaluation, we use EVA, EVA, ML, and is exit function is automated model selection. And the component is a model registry, the technology is a ML flow registry, and the function is a version control staging. Here I am showing that in a picture diagram. For clean structure data, they use a feature engineering. Then ML organization, model training, experiment tracking, hyper tuning. These are the components I'm trying to show step by step in the picture or in my diagram. For inside generation engine, uh, here are the components, technology, and capability. Now we are for the key innovation. Key innovation is a hybrid text image, automatic query optimization, context aware insight generation, and dynamic report template and confidence scoring for insights. As here you see, uh, this is a key innovation. Here I'm trying to show in my pictorial diagram. Hybrid text image is a combined visual for textual data, and automatic optimization enhances the search retrieval performance to take automatic query optimization. And context of insight generation is a produce insights for the tailored data. And dynamic report templating is automatically generates reports with adaptive uh, process, and the confidence score is, for instance, assigns a reliability score to each insights. Here this is the process step by step. Analytics ready data and vector knowledge base, structured data analysis and multimodal analysis is going to LLM QA engine, then inside generation, and then report formatting and strategy inside it showing here and executive reports. There is a deployment and serving. The key feature is the zero downtime and model deployments, automatic scaling with request load, endpoint version and A/B testing, interior API documentation swagger, mutual TLS authentication. These are the deploy when we deploy the our product, and at that time there is the key features here it's showing, and there is the monitoring and for the optimization, the real-time system health monitoring is the most important. When you optimize AI-driven anomaly detection, automated root cause analysis, predictive capacity for planning, and continuous performance optimizer. Here is the we tracking the agent for the time to time updating and upload the data. Here is I'm showing step by step, and here is the page of my coach, and you can visit to my coach and LinkedIn profile. Thank you, sir.
Okay, let me stop.